Welcome everyone. Thank you for joining us for the Utah Energy Code Lunch and Learn training. Today's is called Commercial Energy Code on the Building Envelope in Multifamily Projects, brought to you by Rocky Mountain Power, Dominion Energy, and the Governor's Office of Energy Development. My name is Becky Robbins, and I put these trainings on with Brent Ursenbach, who will be our presenter today. These trainings have helped developers, architects, code officials, and all those working in Utah's building industry gain a better understanding of Utah's energy code. Today's training is actually sponsored by two vendors, which are Owens Corning and Panasonic. As you may know, Owens Corning is a leading manufacturer of thermal and acoustical solutions for building envelope, and Panasonic is a leading manufacturer of ventilation and fan solutions. So we're happy to have them support our training. They and the other sponsors make these trainings free. And as you know, today we will actually have lunch for those attending here. And we will stop our video at about noon, and for 10 minutes we'll give everyone lunch, and then we'll come back on and finish the presentation. I also want to thank Salt Lake Community College's Energy Management Program. There are some materials up here, and you can also find them by going to their website. They're the ones who give us these rooms and register our credits. And so if you ever have questions about your Doppel credits, for those attending today, there's one available. And some of the things I just want to point out is those online should have received all of our handouts. And if you have come in a little later, you're welcome to come up and grab Brent's presentation, the code, and some air barrier insulation checklists that he'll be covering. We also have our commercial energy code brochure, which is always available to anyone, which is a quick guide. And then I just want to bring attention to our commercial training on Tuesday, June 26th and 27th. And those are 3-hour sessions. On the 26th, they will repeat morning and afternoon. And then on the 27th, it'll be just the morning, and that will be at a building shell company. They specialize in building shells named Norda, and that should be very exciting. And the day that we'll have the sessions at the same time, that will cover commercial code related to the building envelope, and we'll have Brent Ursenbach here, and as well as experts from Morrison Hershfield, the building shell consulting firm. So definitely don't miss out on that one. And so I think other than that, just to let you know to please silence your phones, and we will pass the time over to Brent now. And so I'll just quickly run through his background, which is, many of you already know Brent Ursenbach. He was a building official, at Salt Lake County. He's now an energy and mechanical code specialist at West Coast Code Consultants. He also is on many different national and local code committees. He was the president of the Rocky Mountain Gas Association, and so as you know, he's our main presenter for energy code trainings. And with that, I will pass the time over to Brent.
Thank you, Becky. It's good to be here, see some familiar faces. Real quick, and I know that I can't see the people out there on the web, but how many code officials, inspectors or plans examiners? Don't be shy. Okay, contractors? Let's have some contractors. Design professionals, architects, engineers? Okay. Suppliers? Okay, very good. About the handouts, of course, this one is my presentation. I do 4 per page, so maybe you can read them. If you want a copy of this that's bigger, send me an email, and I can send you a PDF that's 2 per page, so it's a little bit easier to read, and you'll have the color on the PDF. This is a copy of every state amendment to the energy code. So if there's a page in the IECC, this code that has a Utah amendment, it'll be listed in here, that whole page, and it shows that amendment on the page. Today we're really kind of focused on commercial, but we are talking residential. And for your information, we don't have any commercial amendments other than one little minor one that just crossed off a couple of words. It has no impact on the code or anything like that. And we have a number of residential amendments, and we'll talk a little bit more about those. You have 2 sheets that I provided for you. that we'll refer to a little bit further on. And I just want to make a note. The Commercial Energy Code is very comprehensive and it's quite complicated. This is a very brief outline of what is in the code. So it doesn't have anywhere near the detail that would be wonderful to have, but you got 1 page, 2 sides, how much information can you put on it? But it's a good guide to get you started, at least to know kind of what's in there. Today we're talking about the building envelope in multifamily projects. And with a limited amount of time, we're going to really focus on the major challenge that we have with multifamily projects. And some of you know what that challenge is, and that is if we are blower door testing multifamily projects, it's hard to get them to pass. They leak a lot, and we're going to talk about why they leak a lot and some of the solutions to that. If you're a little bit weak on some of the code stuff that I'm not going to be able to go over, please stay online, and we are going to hopefully continue doing these, maybe start in August or September again, and try to do them all the time where we just focus on one little subject. So in 2 hours, I can't go over the stuff that I've gone over in other presentations. In fact, we can do a whole day on residential and still not cover everything. If you have a question, though, and you need me to kind of bring it together or even give you a quick synopsis of a piece of the code, please feel free to raise your hand, holler out, and I'll answer your question. I'm not committed to get through every single slide in detail. What I'm committed to is to try to get some information to you that's valuable. My phone number here, I'll be honest with you, I'm semi-retired, and if I am not working, I'm not going to answer my phone. If you send me a text or an email, you're probably going to get a quicker response than trying to call me and get me to answer the phone. And if you send me a text or especially an email, generally you give it a little more thought and I get more information. You know, I get people calling me up and say, well, I have this, and they try to describe the situation, and I really don't know what you're talking about. So if you sit down and try to type it up a little bit, maybe you're going to give me a little bit better information, and I can respond at night or something like that, because I do try to respond to those every evening, and sometimes it's kind of late. Like I bet Becky had an email from me like 12:30 or something this morning. My email address is on the last page, so you'll have that. And Becky already mentioned the Community College, Utah Office of Energy Development. I'm being paid to be a resource on the Energy Code. So I teach. If you have those questions, you can send them to me. You're not disturbing me. You're not taking away from my retirement. I'm being paid to be available and do that. So I'm a nice guy, but I'm not going to give up my retirement to answer your questions without that funding from DOE, Dominion, and Rocky Mountain, of course. And as Becky said, Panasonic and Owens Corning are sponsors. And I also want to recognize DOE's Building America program and DOE's Building Energy Codes program. Both of these websites have just volumes and volumes of information and training, resources and all kinds of things. So if you want to go a little deeper in something, go to those two websites and you'll find a bunch of stuff. And in fact, I grabbed some pictures and I grabbed some slides and mixed it in with some of mine, which they're comfortable with and they have made available. And I just want to recognize them for what they've pulled together. And I mean, it's really, really helpful for all of us. So what we want to talk about today, a couple of things we want to focus on. We want to understand the Energy Code air sealing requirements for commercial and residential multifamily buildings. What is a UL fire-rated assembly? And understand the disconnect or the challenges that we have between the fire code and the energy code when it comes to these ASWs or area separation walls, these fire-rated walls. And then some of the best practices that we might be able to look to improve upon those separation walls. And I don't know how many of you ever go out and are involved after we've had a fire in a multifamily project, but I've been out on a number of them. Gordon used to go out on fire call, and when we worked, he still works for Salt Lake County, and when I did, we would be on fire call, and we'd get called out to make an assessment on the building, if they could stay in the building or whatever. And a newer building that has these area separation walls properly installed really work. I mean, you can see, like in this case, there was a fire started in this one and it came out this window, but you really see it's kind of stopped right there and it hasn't spread over into that other unit. And yeah, they're getting some smoke and heat and stuff, but it's really done a pretty good job, where this one, you know, the fire started here and went right through the roof, but if you notice, the fire came out of the door here, and so it broke through in that older unit into the other one. The fire assemblies don't stop the fire, but they slow the progression for an hour or 2 hours or whatever the rating of that assembly. However, does that stop all leakage? Does it stop all air leakage that might take place? No, it doesn't. When we're looking at the energy code, we're talking fairly small amounts of air leakage. And in fact, the fire might find those little leaks, and that might be eventually the way it works its way through. But by its design, it's trying to stop the progress for an hour or 2 hours, depending on the requirement. Hi, Wendy. So does it stop all air leakage? No, it doesn't. Is it part of the thermal envelope? That's a really good question, because, and I don't have the answer for it necessarily, because when we look at the energy code, we're looking at the thermal envelope, that area or those components to separate what? Conditioned from unconditioned space. Is that demising wall, that party wall, that common wall between two units, does it separate conditioned from unconditioned space? Technically, no. I mean, you could make the argument, well, if a unit's vacant, then we are doing that. We should have some type of, maybe it's a partition wall, you know, where we have a difference in temperature. And the code really hasn't addressed that fully. But if we're looking at air leakage, it does create, and we're looking at testing for air leakage, we have some problems. Because why? We don't build the wall between those two units the same as we build the exterior wall. We don't wrap Tyvek, we don't put cladding on it, we don't do all these things, and so we have some leakage. And then by the way we build the walls, you know, shaft wall liner is a very popular way to build multifamily now. But with that, we have the potential for a lot of places that air can move through if we're testing. So, and testing is an option both with residential and commercial multifamily. Are there any other issues with these walls? And I'm going to give you a hint: leakage. What leakage are we concerned about? Of course, we're trying to stop fire from moving through the wall. I'm sorry? Airflow. Airflow, air movement. You know, so we want to maintain air within our space. What else are we trying to control? We're trying to control sound. And have you ever lived in an apartment and you lived next to someone that cooked different than you did? What's our issue? Smells, odors. Whether it's smoking or what they cook or whatever the case may be. We're asking that wall to do a number of things. And for those that are contractors, and I've had a number of contractors call me and say, this is, well, I won't say exactly what some of them said. This is ridiculous, you know what I mean? I'm having to seal up that wall and I don't need to because I meet the UL listing for that wall. would they want to maybe be concerned about sealing that wall so that they're not getting complaints about the odors and the sound and all those other things? So we can do all of them together. We can address the firewall with the fire assemblies, but then the sealing that we do does more than just help us pass a blower door test. It helps with sound and it helps with the odors. So it's a bonus for meeting that requirement. And I'm not defending necessarily. Maybe we do need a different standard for multifamily, because if it's just leaking into the other unit, that's really not energy. I'm just saying some have done some things on that, and it's just something to think about. So what is the difference between a commercial and residential project? A lot of you know this, and you're going, oh my hell, I've heard this 100 times. Well, for the benefit of everybody, I need to explain how it works. If we build a 3-story apartment project, we build that out of the commercial codes. We build out the IBC, the IMC, the IFGC, and the IPC, and NEC. That's a commercial building. But that 3-story residential building, R2 building, is a residential building in the eyes of the energy code. How townhouses, what is a townhouse? It's a single family dwelling with a 0 lot line. So this is 1, 2, 3, 4, 5, 6. That's 6 single family dwellings. And so they are definitely residential. Each one of them a separate home. And we build those completely out of the residential code. So this, everything's residential. This, we build out of the commercial codes except for energy, and then we use the residential energy code. That makes a difference in Utah because our residential energy code is heavily amended. There's lots of amendments to it and such. So 1 or 2 family dwellings, townhouses of any size, and R2s, 3s, and 4s. So that's everything except hotels and motels, basically, are R2s, 3s, and 4s, and the single family dwellings. 3 stories or less is a residential building, according to the energy code. And I just put in what the R1, 2, and 3, and 4 are. Buildings that are not residential by definition, if they don't fit this, they are a commercial building. And so we go to the commercial energy code. The first 2/3 of this is commercial energy. This last third is residential energy. So do we need to comply with the commercial provisions? Yes, here's a 4-story apartment building where we had the 3-story here. You know what, you can have 3 and 4-story units, buildings on the same project. You actually have 2 different energy codes that you need to be looking at. So yes, and even if it's 3 stories of residential and then retail on the bottom, is 4 stories above grade, so it's a commercial building. It's how many stories above grade. So what is the building thermal envelope? That is all those components. We know what they are, the roofs, the walls, the windows, the skylights, the floor assemblies, slab edges, below grade walls, those assemblies. So all these components that separate or are a boundary between conditioned and unconditioned space. And that is why we might say, well, really that wall, that demising wall, is not part of the building thermal envelope. But the code really doesn't make a distinction on blower door testing. If you choose to blower door test, or if the code requires you to blower door test, it doesn't give you an exception for that. We'll talk about some ways you can get it to pass that the code really hasn't addressed. So energy, what are we looking for? We're asking the envelope to, that envelope assembly to do what? Reduce the energy required. So anything we can do, whether it's a home or an office building or this building, anything we can do to that thermal envelope to stop the transfer of heat out in the winter or stop the transfer of heat in the summertime reduces the energy required. That's simply what we're trying to do. And major factors is the conduction, the heat that flows through the components, and then what we're really focusing on today is the air that is transferred by convection, or air moving through that envelope. If we move air out of the building, we have spent money to condition that air, and that adds to our energy expense and our heating load. If we have air migrating in from outside in the summertime, the same thing, or in the wintertime. So that convective flow in and out of a building adds to our heating load. So part of the code is to build with better insulation, and another part is to reduce that air leakage. And so that's what we're really focusing on today. What's the energy code done? I thought this was a good slide just to put in real quick. I remember back in the early 80s doing MEC checks, Model Energy Code, and it was the precursor to Res Check. I remember it coming out and doing MEC checks. And in 86, we had an improvement. We had a 10% increase. And then we kind of wandered along without not too much change, a little bit of bump here and there. And back in about 2006, and Paulette remembers this because we were working together with on doing some training. Yep. And that's coincidentally, 2005 was when I retired from HVAC and became a code official, and that's how I got involved in it. HVAC people, you know, if they're doing load calculations, what are they doing? They're looking at how energy efficient is the building. So it was a real smooth, easy transition for me, who had done heat load calculations forever, to move in and be a resource or to understand the energy code. So in 2006, the energy code simplified itself. It was pretty complicated, and hardly anybody was enforcing it. So in 2006, they simplified the code, made it a little bit easier to enforce, and we started seeing these jumps in efficiency or improvement or energy savings. And this is 2012, and the 2012 to 15 really doesn't have that much in it, some cleanups and stuff like that, maybe 2 to 5% at most is the improvement there. And the 18 code doesn't do a lot more either. Our challenge here in Utah is we are really, depending on which path you use, we're wandering around someplace in here as far as what our energy code does. We allow some things that haven't been allowed since 2006 in the energy code, and then we picked up some of the good things too. So, does this matter? I think it does. If every building we build is 30% more efficient than it was 10 years ago, that's a significant reduction in the amount of energy we use across the country, and maybe preserve a few resources and maybe reduce some emissions and stuff like that. So air leakage. We have some mandatory requirements. Now what I'm going to do is go over real quick the commercial requirements and the residential requirements so that we kind of have a feel for it, and hopefully we can get through those about the time we break for our lunch for a few minutes, and then after that we'll kind of go into the assemblies that we're using in multifamilies, and you can kind of see what's happening there. So on the commercial side, these are the things that are addressed in the commercial code. Air leakage, air barriers, fenestration, air leakage, or our windows and doors, rooms containing fuel burning appliances, and we're not going to say anything on that today. Air intakes, exhaust openings, stairwells, shafts, etc., loading docks, we're going to ignore that one today. Vestibules, we're not going to talk about that one today. Recessed lighting, and as I said, we really don't have any state amendments that affect commercial leakage. How does a building leak? It leaks by 3 different methods, or 3 different actions that are put on the building. The first one's stack effect. As you have a taller building, and it doesn't have to be that tall, when you have a building and you heat air in it, or we produce heat in it because we live in that building, we're going to have warm air rising. The heat doesn't rise, the air that's been heated rises. And it goes up and it literally puts a slight positive pressure on the upper part of the building inside and a slight negative on the bottom. So just by conditioning air in there, by living in it, by occupying it, by letting the sun in through windows, we have a heating effect. And when we have heat in that building, it tends to rise, and it actually creates this convective flow where it sucks in air at the lower levels and pushes it out at the upper levels. And you can actually measure the pressure differentials between the two levels, and it's higher when we have higher temperatures. Second one is wind. I mean, we've had plenty of wind the last few weeks here, haven't we? That impacts how much air is moving through our building. And that's one of the big reasons that we do air sealing. I hear complaints all the time, well, we ought to just let our buildings leak, then we don't have to worry about air quality and everything because the air, it'll just clean itself. It's self-diluting as all this air moves through it. Well, that's great when it's not windy, but when it's windy, then we have this massive uncontrolled leakage of air just pushing in through our building, and our energy expense goes way, way up. And in fact, our ability to condition our building goes way, way down. You just simply can't keep the building comfortable because of that air moving through it. And then our mechanical systems, we create pressure differentials within our building by our mechanical systems. We create it by exhaust systems. We create it by imbalance between return and supply. We create pressure differentials because we move air through the building mechanically. And any one of those things can increase the movement of air in and out of a building. One last thing I want to touch on is if we exhaust air out of a building or we lose air out of a building, it's going to be replaced. It's going to be replaced by leakage someplace. If the building is so tight that you turn on your exhaust fan and it can't replace it, then it doesn't exhaust it either. You know, it reaches that equilibrium point where it's exhausts as much as it can based on what can leak in. And when we add up all this together, that's what we have is our total convective flow in and out of that building. So, and we'll circle back to this, our multifamily building, we might not call these walls part of the thermal envelope, but if we are losing air and it gets in that little airspace and it does go to outside, then it is part of the thermal envelope. And I'll have some slides in here that I'll bring that point home a little bit better. Any questions on any of this? I'm going pretty fast. Still on the commercial side, the commercial energy code is not that different than the residential code. The residential code without amendments actually would say you're going to do insulation right, you're going to do weather barriers right, and you're going to blower door test. The commercial code doesn't say that. The commercial code says a little kind of what we say in Utah by amendment on the residential side, and that is we need to make sure that we do a good job of sealing the building envelope, or we blower door test or pressure test the building. And so both residential and commercial have that option. Are you going to make sure you seal and do everything really, really well, insulate properly, or are you going to test? And so it's really, the testing's a little bit different, but that's really the bottom line. Are we going to test, or are we going to make sure we do that correctly? Now, if you're going to do that correctly and seal all those components, then there's a lot of stuff we're not doing in multifamily right now, and that's why they're not passing. So here's a set of apartments, and guess what? They're putting a blower door on every one, and they're testing 3 of them right at the same time. How many have not seen a blower door test? Be brave. There's a thing on the internet. It's called YouTube. You ought to go online and watch a video or two on a blower door test. And it's kind of interesting what they do. But we literally depressurize or pressurize. In almost every case, we depressurize that unit, that dwelling, that apartment, that building, we take it to a reduced pressure or we take it to an elevated pressure, and we measure how much air moving into that space or out of that space is flowing, and from there we determine a leakage rate. If you had a perfectly sealed building where there was zero air leakage and you put a blower door on it and took it up to 50 pascals or 75 pascals, depending on if it's commercial or residential, there would be no air moving through the fan once you got it to pressure because you're not leaking. What we're doing with a building is really kind of, you have a gash in the tire, so it's leaking air, and you hook up the air hose to it, and you can maintain 32 pounds in it as long as you have the air hose hooked to it. It's the leakage rate. That's what we're doing to a building. We're just trying to see how we take it to a certain pressure, how much air we have to keep putting in, and from that we determine how much it leaks. It's pretty simple. So again, we make sure the envelope is tightly sealed based on a bunch of recommendations or a bunch of requirements in the code, or we test it. We do test at higher pressure. For commercial, we test at 75 pascals instead of 50, and the leakage is based on square footage rather than the cubic footage or volume. But in either case, we're determining how bad the building leaks. If you blower door test in either code, you have some mandatory requirements you have to comply with, and we really don't need to go into depth on that, but basically in either residential or commercial, blower door testing doesn't excuse you from making sure you have dampers on your exhaust or your intakes and some of those types of things. So still in the commercial, the commercial code says you have to have a continuous air barrier. And what's that air barrier? Well, it's components of your building. It can be, and it can be on the inside, it can be on the outside, it can be located in assemblies composing the envelope or a combination of all those. So an air barrier can be your OSB on the side of a building. It can be den shield rock on the outside of a building. It can be your drywall on the inside of the building, as long as we seal all the edges and seams and all those types of things. So it can be a combination of all those things, or you can simply wrap the thing in Tyvek and then make sure you caulk and do those things. Whatever, we're trying to maintain an air barrier. Understand that an air barrier or a weather barrier is not a vapor barrier. A vapor barrier is a visqueen product, and that's not what we're talking about here. We're talking about moisture transport there, and that's really not what we're talking about. These air barriers actually stop the air from moving through, but if there's moisture within that cavity or whatever, they allow drying. So they are not vapor retarders, they are air barriers. Paulette?
In Las Vegas, they use the continuous insulation, the one-foot stucco system, for their air barrier, and it was extremely effective.
Yeah.
I see that a lot here.
Yeah, for those in the back and those out online. In Vegas, they use an EFA system, a stucco system with continuous foam, and you know what? It's a very effective air barrier system, as long as you make sure your windows and your penetrations and all those types of things are addressed, and where you get to the top and the bottom and stuff. But yeah, it can be very, very effective.
Until the magpies.
Yeah, unless the magpies or the woodpeckers want to bore holes in it. Yeah, and the thing that's important here, we have continuous, we have some continuity for these assemblies or these parts of the thermal envelope and across the joints and assemblies, and that's where we have challenges. That's where we have challenges in residential homes. We might be thinking we're going to use the drywall, but we have issues at the top of the wall, or we have issues getting into the walls. Interior walls leak too, because the air gets into the interior wall and then leaks between the drywall and top plates. And I mean, there's lots of places that air can leak. So the commercial code really talks a lot about the joints and seams being sealed and all those transitions being sealed. And that's really where we find leaks anyway, is at joints and seams and where dissimilar products mate together. And what are we doing? We're trying to resist the positive and negative pressure from the wind, stack effect, and mechanical ventilation. This is all from the commercial code. I'll kind of move through it fairly quickly. Penetrations of that air barrier. You know, I see this, and I've seen it for a lot of years, and I was probably guilty of it as a HVAC contractor. We go onto a building and we drill a hole in the side of the wall and to run refrigerant lines and stuff through, and what do? We seal to the cladding. Are we sealing inside between the brick and the sheathing or any of those no, lots of times not. So really that's a little bit more than just sealing right at the face of the cladding, because we have air spaces created between cladding and the building structure. And so fortunately, you know, the industry's learned, and we're seeing little boots and everything that you can put on the walls, and you probably sell some of those things in your supply house that you can put on the wall, that you merge your weather barrier into, so that we have that tight air seal where those penetrations take place. It's really tough for those that are code officials to catch all that stuff, because we are not there every step of the way. You know, I've been on both sides, and I can defend both sides, but it's tough for a building inspector to catch every one of those transitions, every one of those penetrations, to make sure they're sealed correctly. But maybe we do need to do a better job in making sure where the line sets are coming out or where fans are coming out, that we make sure that, and I'm not pointing my finger at you, Wendy, because I know you do a perfect job up there, right? We need to make sure that penetration, if it's Tyvek, we need to make sure something's done at that Tyvek point, because it needs to maintain its continuity. It's not just most of the area where you make those penetrations. Those that test in here, I think, can attest to the fact that those penetrations can be a big source of leaks. Sealed with tapes or coverings with moisture vapor permeable wrapping materials, concealed fire sprinklers in a manner required by manufacturers. Now, you got to be careful on fire sprinklers, and there's been a lot of debate on this and the location of the heads and everything, but we can't get gung-ho and say, now these heads are exposed, but you've seen the blind heads where they just have a little cover on them. Those little covers are set down just 1/8 of an inch or so off the ceiling, and when there's a fire, that heat comes in through and gets up inside, and that's what melts the fusible link. So we don't want to be doing any sealing around any fire sprinkler head that's going to impede the proper operation of that head. Now, maybe at plan review, we need to look at that a little bit if we've got a lot of those penetrations and see if we can address that some other way. But we have to be cognizant of that. Recessed lighting in both residential and commercial requires that your can lights are sealed where they penetrate your ceiling lids. And other similar penetrations. We need to make sure there's provisions to maintain that. You know, can lights are very, very popular, and boy, I've sure seen a lot of leaks around can lights.
Can we go back really quick to that sealing of fire sprinklers? I have never been able anywhere to find a manufacturer give me recommendations on how to seal one of those, other than I don't seal them and I take the penalty, and then essentially not being able to get that CFM credit that I needed in my air leakage. I have to make it up somewhere else.
Right. Yeah, the question,
Found that.
the question is, how can we seal those? And you're right, we really can't seal them. We have to rely on the manufacturer's instructions. And so, yeah, you take a hit, you take a penalty for it. If our goal is really to build that airtight building, maybe we need to look a little bit about how we are running our sprinkler lines. You know, when I was doing HVAC, and I did a lot of multifamily, my company probably did 5,000 multifamily units. There was a lot of running around in circles trying to figure out how to install those systems and maintain the integrity of the fire separations at the ceilings and everything. And you know what really works out best is you go into a unit and you put a lid in it, a drywall lid, and seal it off. You have a fire assembly with the membranes and everything, and it's complete. And then put everything underneath it and drop again. And the same thing would apply to fire sprinklers, you know what I mean? Let's create that envelope and then bring it in. And I think, I mean, the effort I see, and I inspected a lot of multifamilies. We had a pretty big project, didn't we, Gordon, that was just wrapped up before I retired. And oh my heavens, with all they did some of that, but we still had places. We had fire dampers here and there, and accesses here for them, and labels for the fire dampers, and all these contortions we had to go through to get that thing to work. And I know it would have been cheaper if they just put that lid in, you know, made some careful thought and put all those things, fire sprinklers and everything underneath, and just maintain the integrity of that rated assembly without the penetrations in and out. And so really you can't seal around them. They have to have flow through them, so the best way is bring them underneath, have a air barrier, and then do everything underneath it. Great question. Yeah, I've seen it all. I mean, the expense of trying to wrap up around and in floor joists so you can run stuff through it, and to have a listed assembly that you can do that. I mean, it just is so labor intensive. People in and out and in and out and in and out trying to create these, and then we have ends, and it's just a mess. So, excuse me. It's a challenge. And the manufacturers, I think one of them allows a boot or something on top of it, but it has to have a certain volume so that we get some flow. So, commercial still, our air barrier compliance options. There's two ways to comply. We use materials that are identified in the code, and in fact, they're identified on this sheet right here. We use materials that are identified as having an air permeance or an air leakage that's less than or equal, 0.004 CFM per square foot under a pressure differential of 75 pascals. And so we have this whole list of materials that can be used as an air barrier. Now, we don't think of OSB as an air barrier. Why? Because of all the seams, right? So it's just easier to put a piece of sheet of Tyvek over it than it is seal all the seams. OSB is a legitimate air barrier, but we have to treat the seams and edges correctly so that it's sealed, which is the easiest, But that qualifies, and you can see on the list of all the other things, plywood, OSB, extruded polystyrene, only a ½ inch, and when they put 2 and 3 inches on the outside in multiple layers, I mean, that really tightens up. Closed cell foam and so on down, cement board, exterior gypsum or interior gypsum. Yeah, gypsum wallboard is an air barrier. It meets that ASTM test. You can't push air through the gypsum itself. Now you can if you don't treat the seams. So you use a bunch of approved materials, treat the seams, or you have certain assemblies that have been tested and that industry has actually tested. And so here's our list of materials. And if it's like a membrane roof, that works. Modified hot mop roof, that works. We have all these things that can qualify and meet those requirements. So we use all those materials, or we do assemblies that have been tested according to one of these 3 ASTM standards. And for example, these aren't the only 3, but these are 3 mentioned in the code. If you have a CMU concrete masonry wall coated with either an application of block filler or 2 applications of paint or sealer, or a masonry wall constructed of clay or shale, or you put a Portland sand, parge, stucco, or plaster at least a ½ inch thick. Those 3 masonry assemblies have been tested. If you use standard CMU block and you try to pass this test, it won't pass. The CMU block leaks enough through the little voids in the block that it won't pass the test. But if you put 2 coats of paint on it, or you put block filler on it, then it'll pass the test. We don't need to go any further than that. We just have to verify that they use block filler, or they put the 2 coats of paint, or whatever. Or they use the other components, or they did the plaster on it at least ½ inch thick. And there may be other cladding products that may comply with this test. I'll be honest with you, I don't know what Nord is going to be talking about when we talk about the cladding systems in a week and a half in this next training, but they have sheet metal foam insulated cladding systems, and I don't know if those have been tested and if they seal edges or not. I guess we'll find out. But there might be other systems that we are putting on the outside of a building that will pass this. And your example of the foam, yeah, that would be a system I'm sure has been tested before, and it easily would pass that test. Windows. So our windows need to, and windows are tested, and there's test procedures, 2 different test procedures, or 3 of them, to test windows and doors and garage doors and all those things. And if we make sure all of our components have this, then we're fine. What do we do if we have site-built assemblies? Well, if it's site-built assemblies, we have 2 options. The code official can actually look at that site-built assembly and see if they can make the judgment that, yeah, that window system is gasketed and caulked and sealed. I'll make the judgment that it's okay. Or what? You blower door test, just like on the residential side. We don't want to go through all this, and we don't want to have all these inspections to verify every panel edge was sealed and every box, or we're using drywall, every box is sealed and all those things, because that can be pretty complicated to get all that scheduled and get all that visually verified. And it might be easier just to test it. And then we can, as contractors, we can decide what we want, which path we want to go. And we can also decide which areas of sealing work best for us, which is the most bang for the buck, which one provides the most effective sealing for the dollar we spend. Because quite honestly, you can probably focus on certain areas, like we have builders that just automatically now on single family and multifamily that spray foam rim joists. And you know what? It takes care of a lot of leakage, and it meets another requirement in the code. And they've decided, you know what? I'll do that. It's going to cost me a few bucks, but it solves a couple of problems for me. Now maybe someone else will say, well, that one, I don't want to spray foam. I'm going to blower door test, and I'm going to focus on some other area. The code really gives us some options, but it really is. We do a really, really good job it's observable and it's inspected, or we're going to blower door test. And if we're going to blower door test, we're still going to have to do some stuff right, so it'll pass the test. Okay, residential. And I know at least half of you have probably seen or listened to me at least once, twice, 3, 4, or 5 times talk about the residential requirements in the code. Without amendments, if we just adopted the 2015 IECC without amendment, every residential building would be blower door tested, and we'd be verifying this list for the residential building. We'd be verifying that all this took place, and we'd blower door test. That's what the residential code says. We will do all of this, and that is going to ensure that we have a tight building. And a side note that we're not going to really talk about today, if we were on that full code, then we'd be mechanically ventilating everything, because the building would be tight enough that we'd have to make sure we continuously ventilated with an exhaust fan, bringing some air in as a supply, or an HRV, ERV, some type of continuous mechanical ventilation. That's really where the code sits today. For our climate zones, all of our climate zones in Utah, we would blower door test everything. We'd make sure we installed all the insulation right. We'd mechanically ventilate everything. And we'd have a pretty good building. We'd have a really good building. And then we'd be that chart, you know, we'd be at the very efficient and very effective building and use less energy. By amendment, well, let me back up. And when we blower door tested, climate zones 3 through 8, Washington County is climate zone 3, we're in climate zone 5, up to the higher altitudes and north is climate zone 6. We would have to test to 3 air changes per hour at 50 pascals or lower. 3 would be the maximum. And which would trigger mechanical ventilation. So that's what we'd be doing. By state amendment, we can do either the blower door test, kind of like we can do by code in the commercial side, or we field verify. Now I'm here to confess that we, as building inspectors and plans examiners, haven't been doing our job in ensuring this list is followed if they're not blower door testing. And hopefully over the next year, and that's one of the focuses of this training, is to get everybody up to speed so the contractors and those code officials and everybody else understands we should be doing every single thing on this list or blower door testing. And the builder might not be doing it because he doesn't know about it and no one's asking him to do it. Or the design professional might not be putting it on the plan because he doesn't know about it. You know, it's really a team thing. Can we all get together and kind of get on the same page? And that's really a focus. And that's really the focus of the Governor's Office of Energy Development, and you know, providing funding to Becky's group and to me and to others to try to raise the awareness and try to get us doing what we should be doing on this. And you know what? It works. If we were doing this, we'd have more efficient, much more comfortable buildings. They're really, the only downside is it might cost a few bucks, but you know, when you change your process, you know what, you soon learn that maybe it isn't that expensive. Maybe you refine your process and you do better. Paulette?
Well, usually if you're doing all of that, your building is more energy efficient, therefore the tonnage of your units decreases.
Absolutely.
And so therefore it's a wash, you get a better performing building, and it's not going to cost you.
Yeah.
You are actually going to save.
You need less heating and cooling.
Better comfort is a big thing to sell.
People demand comfort today. When I first started doing HVAC in 1972, we rarely set air conditioners with the initial installation, even in Pepperwood. It was, oh, we'll see what it's like in the spring. Do we build homes today in Salt Lake Valley without air conditioning? Nope. The smallest home has air conditioning on it. My first home I bought in '75 didn't have air conditioning. I put it in real quick as soon as it got hot, but we demand comfort. We really demand comfort.
One comment on this list, if you do this list, you will pass the blower test. But what happens is so often as people don't do this, and when we get to the blower door test, then they're trying to figure out how to pass it.
Right.
And many of the things they do are really not cost effective for the builder. They really, because they're trying to find where they missed.
Yeah.
That's essentially what it is. So this list here.
The list will make you pass, and you'll pass easily.
Exactly.
Please.
I am very with this, so I'm sorry, this is a stupid question.
No.
With the blower door test, do you test every door, exterior door? How does that work?
Nope.
What do you test?
Nope. What you do is you take one exterior door. That's a great question. You take one exterior door, and here we go. And this is great because we can. This is literally a portable door. So you stick it in the front door or the back door or whichever exterior door you want to. You have this controller and it's an electronic measuring device, but we literally typically depressurize the house, take it to 50 pascals. And you turn the fan up until you get it to that 50, and then you measure how much air is having to move through the fan.
Right.
And
it's one door.
And it's one door, and the rest of the building is just sealed up.
Okay.
And then so you're doing a whole house test. Question?
So how do you do that on a 100,000 square foot, 3-story building?
Multiple blower doors. I mean, if you go on, punch in blower door test, commercial buildings, and you'll see like a big door open with 6 or 8 or 9. And actually, in some of the big buildings, if you have a really sharp controls guy or a building engineer, you can actually pressurize the building to 75 pascals with the building HVAC system.
That's a question with the building HVAC system. Are you allowed to cover on a blower door the economizers?
I would say yes.
No, okay, then
Yeah.
then it can be passed.
Yeah.
I can see that, but with it, you can't cover those economizers, you might have a problem
Yeah.
passing that.
Yeah, you could close dampers and stuff like that because the dampers are going to be in various stages when the building's operating, but what we're testing is the leakage of the building.
Yeah.
We'd verify that the dampers were manufactured to the proper leakage rate because dampers are all rated.
Okay.
Yeah. Great question. I'm glad you asked. Seriously, go to YouTube's great. You go to it and watch it. I mean, it's really it's not a complicated thing, but it's very effective. And you literally measure. There's a tube that you send out the front door to get away from the door, so you can measure outdoor pressure, and you measure indoor pressure, and you take it to 50 pascals, or in a commercial 75 pascals, and you see how much air. This literally measures how much air is going through the fan, and from there you calculate your leakage rate. I'm just going to hit a couple of things, and then we're going to grab our lunch and take a 10-minute break. So this is the code requirement, 3 air changes per hour. Here's just kind of a summary of that inspection checklist, just a partial table, and it talks about all the things you need to do there. On here, one thing that you need to be aware of that people aren't doing, it's mandatory you have an air barrier at your rim joist insulation. So if you're tucking a piece of fiberglass insulation in a rim joist, it doesn't have an air barrier on the inside surface. And to cut an air barrier to fit that and caulk it is ridiculous, and so spray and foam there works. If you have a knee wall, where you have drywall on one side and attic on the other side, you have to have an air barrier on that. Insulation, the real driving thing in this table is all insulation has to be enclosed on all 6 sides, all vertical insulation. So if you have a wall and you're not drywalling on the back side, you need to enclose it, because what do we have? A top and bottom plate, drywall on this side, stud on either side. That 6th side is the back side. And so that's the real key to proper insulation. By amendment, in Utah, we only have to pass at 5 air changes per hour. But guess what? January 1, 2019 isn't that far away. Then it's 3.5, and then January 1 of 2021, we're down to what today's code requirement is. And so come next January, 3.5, and you are not going to get away with the stuff you get away today. 5 is not hard to hit. 3.5 is going to be harder to hit.
And then does it go down to 3 in 2020?
2021. And maybe in 2021 we'll adopt, well, in 2022 we'll adopt the 21 code, because we're not even considering the residential code right now. I'll tell you, the recommendation has been made that we adopt the 2018 commercial energy code. Nothing on the residential, but we just made the recommendation yesterday that we adopt all the 18 codes except for IRC. And that's legislative action told us not to do that.
What about the McMansions? Are they under commercial or the?
Oh, they're residential. Unless they get real tall, then you might, at 4 stories, you might end up having to trigger over into, but that's an IBC discussion on great big homes. But I did some 20,000 square foot homes and we did them residential.
Right, yeah, that's the problem.
Okay. Let's break for one question, then we'll break.
That one. So if you have a residence with basement and then 3 stories,
We're just talking stories out of the ground,
Stories above grade.
above grade.
walk out.
Yeah, we'll still call that if the grade some places that, you know, I mean, it's not considered fully out of the ground unless it's fully out of the ground on all 4 sides. I found that out trying to get a building permit when there was a floodplain issue. Okay, let's take 10 minutes. Those that are not on the web, we'll get back at it 10 after or so, 10, 12 minutes after. Thank you. Well, we're back. Everybody is having their lunch here. I hope so. Those out on the web had a minute to take a break and maybe grab a bite to eat. We're going to try to finish this up in the next 45, 50 minutes. I wanted to say one thing that I didn't say earlier. We really would like your input on if you like this format that we do, a 2-hour lunch and learn every month, a different subject. We'd love your input on what subject you'd like to hear. And the other thing is, I'm trying to keep track or trying to identify what works best and where we're getting some effective education and better compliance. And so one of the things that I've found that's been effective for me has been when a jurisdiction calls up and says, hey, can you come in and talk to us at staff meeting? Or can you come in and we'll look at a plan for a couple hours? And I attended your class and I understood it real well until I opened a plan and then I had some questions. And so I'm opening up. I don't know, if I get bombarded, you might have to wait, but that's one of the things I'm going to try to do more through this next year. Our contract year starts at July 1, and that's to meet individually with smaller groups. And so if you're an architecture firm or an engineering firm or a builder group or whatever, and you have something specific that you'd like me to come and meet with you on, I'd be happy to do that, and we'll see how that works out. You have my contact information on your handout. I have some cards here. I am, like I say, I'm doing all of this through West Coast Code Consultants, who I now work for part-time, and they're doing the contract with the state, leaving me the time to do this stuff rather than me doing the paperwork and the logistics side of it all. So feel free to reach out to me if you appreciate it if you sent me an email, what your thoughts are, what you'd like me to do, what you'd like me to focus on, because there's so much that we could spend time on it if you give me a little idea, and then I'll trying to schedule those July, August, September, moving forward. Okay, any questions based on what we talked about earlier? Really summarizing real quick, we have a thermal envelope. We need to build it right. We need to seal it right. We need to insulate it right. And theoretically, we would follow these checklists and test it, and then we'd make sure we had a really good envelope, and we'd know. Building testing is coming, and duct testing and all these things they're going to be just the standard in not that many more years. And in fact, they are almost the standard if we didn't amend the code. And that's okay. We've made progress on the code. I don't want to sound like we haven't made progress. Sure, I wish we didn't amend it the way we have, but even with the amendments, we've made a lot of progress. And we're doing a lot better than we were in 2006 when we first really started focusing on energy codes.
How many people are going to start shooting for the 3.5 and get to 3.0 and have to put in the recovery systems? Is that going to be a problem? People not planning on it.
The question is, how many people are going to be shooting for the 3.5? They hit the trigger of 3, they go below 3, so they have to mechanically ventilate. Do you know what? If you're building and you're hitting 3, you should be mechanically ventilating. You really should be mechanically ventilating.
Well, they're not going to plan for it.
Well, I'm glad you brought it up, because I'm going to focus on this as we get closer to the year, that if you're blower door testing, you probably better just plan on mechanically ventilating. Now, we talked last time, and I'm just going to several times we've talked about it, but real briefly, you can mechanically ventilate simply by putting in a good quality fan, like the Panasonic or Braun or some others make them, set them at a low CFM, whether you need 45 or 60 or whatever CFM you need, let it run all the time. Could be your master bathroom fan, so part of your cost is offset because that's a fan you need anyway, and let that run 24/7. When you walk into the bathroom, either by switch, occupancy sensor, or humidity, it goes to a higher speed. The reason I say you should plan on it, because as we build a building tighter, even in dry Utah, we create moisture by living in our houses. We breathe, we bathe, we cook, we do all these things, and we create moisture within our house. And if we don't get it out of our house, we're looking for a potential problem. And we might not see it because it might be within our wall assemblies or something like that. So I would say, if come January, and I'll start teaching, and preaching this, is we really probably ought to be looking at mechanically ventilating those. We don't have to do HRV. That's not what the code says, or ERV. We can do it with just an exhaust fan. Wendy?
Okay, so that takes care of the exhaust. What about the intake?
It'll leak enough in.
You think it will?
The code allows you to do exhaust, supply, or a combination of supply and exhaust. And until you get really tight, you're going to leak enough in. I mean, the typical continuous ventilation requirement for a 3-bedroom house is somewhere the 60, 70 CFM, 80 CFM max. It's based on people and square footage. Well, what have we kind of decided in code development? We've decided when we exhaust 400, we can't leak enough on the kitchen side. And so if we're less than 100, our dryers move around 100. If we're less than 100, we're going to be able to leak it in until we get really, really tight. Now, if we're testing, I don't know what the trigger would be. If we're testing below 1, then maybe we ought to be thinking about a balanced ventilation.
I think that's when you go into like CAS problems. If you recognize any kind of CAS problems, you need to have some other types of ventilation.
Yeah.
But if you're not running to negative pressure where it will cause combustion air problems,
Yeah.
and I don't think you really have that problem.
Yeah. And the comment was, we start running CAS problems, or combustion air problems, you know what I mean? We really solve those by just going direct vent. H.
Hey, Brent, I should emphasize that the fan system has to be designed very carefully, because typically a 100 CFM fan maybe gets 50 because of the ducts and the so that don't underestimate, don't put a 100 CFM fan and expect to get a
Yeah. The comment was we have to be careful on fans, and if that 100 CFM fan is really going to truly move 100 CFM. That has been a point of discussion, and actually the code's starting to identify when we put in an exhaust fan, if it's moving 100 CFM, it actually gives us some direction on the residential side on what size of duct and how much flex and all that stuff we can use. So you bring up a really good point. We all know that 50 CFM bath fan that's been installed forever that you can buy for $12, at best moves 20, at best. And so, yeah, that's a good point. Okay, commercial and residential. Now let's get into a little bit of this. And I've had some phone calls on this where I got a call and said, I got a multifamily, it won't pass, and it's townhouses, and so I put a blower door in each unit on both sides, and it passes. Because why? We have the same pressure inside, so like this one here with one underneath. So all the adjoining units, they put a blower door in, and they just test this unit. Well, what does it see here? It sees no difference in pressure because they're both sitting at minus 50 pascals. You see what I'm saying? And then they pass because we're not drawing air from these ones beside it. And we call this guarded blower door testing. You can do the whole building at one time. You do a single unit, you are going to be drawing air in from the units that are adjoining it. If you, like I say, typically it's, does anybody ever positive pressure? I don't know if I've seen anybody that does positive. They all take it.
The only time I ever done positive pressure is on existing homes where you're trying to meet low-income housing type things. The only reason why is because you don't want to draw what's ever inside, build up inside the wall into people's breathing area.
Yeah.
But positive pressure, anytime you do that, you're opening dampers, so you have to go around and seal the...
And seal all the dampers, yeah. Yeah, the comments there was, yeah, typically it's tested by going negative. His comment was, if you're testing a really old house and you take it negative, you're drawing all the crap from inside the wall cavities that's collected for 100 years. Is that your comment? Okay, thanks. In those cases, you might go positive, but when you go positive, then backdraft dampers on all your exhaust fans and everything, you have to tape over those because you're going to push them open rather than pull them shut with your fan. But it really doesn't matter whether you go positive or negative. If you take it at 0.2 inches or 50 pascals or 75, it's going to basically leak the same. Now that's not 100% true, but it's close. So is it legal to do this? The code doesn't say you can't, does it? Code doesn't say you can't. So I told him down there, yeah, this was out of Washington County. I said, but if it's leaking that much from the other units, the builder ought to be aware that it's going to be leaking whatever people are cooking on the other sides. And so it's a great tool to identify if you're fairly airtight and going to be preventing some of the noise and the odors and stuff that transfer between units. Paulette?
Did anybody check with ResNet and their guidelines as to testing for commercial? Because I know they have guidelines. Do you know if...
I looked at that and I don't remember. My hair's white. So what are we asking Assembly to do? We're asking it, of course, to protect us in the case of fire. And we don't need to spend a lot of time on this, but there are tests done on all these different assemblies, and those that are code officials are aware of this. The gypsum people and UL have all these assemblies that have been put together and put in a test lab, and they have tested how long it takes for that assembly to fail. And they are listed assemblies. And when someone comes and proposes something that isn't a listed assembly, we have a challenge. But we have these listed assemblies, and the testing is specifically on, does it hold the fire for an hour or does it hold the fire for 2 hours? There's nothing in it that tests for air tightness like a blower door test does. Nothing whatsoever. The best known test is the ASTM E84 test, known as a tunnel test. And it also looks at flame and smoke spread and those types of things. It's a measure of the containment of the fire within a room or a building. It's protection against fire penetration of a wall, roof, floor, whatever. And that fire might start on the other side by radiant heat or whatever, however heat transfers through. You know, it might burn through, but you might get hot enough on this side that it'll light on the other side. And in fact, in the case of metal studs and metal framing, you actually will get crossover quicker because of the metal heating up and radiating through to the other side. But they test for that. And so they have listings for metal studs, they have listings for wood studs, they have listing for I-joists. You know, I-joists burn really quick. You know, You have to do different assemblies. So you have to go to those standards and identify the assembly. And they test for how that assembly is put together, screws and everything else. And it gives time to discover a fire, to suppress it before it spreads, and to evacuate the building if needed. And it is rated in hours. And this is, of course, one of those pictures of shaft wall liner. How many are familiar with this? I know Gordon is, and some of these code officials and some of you builders. It's, well, I have some examples of what we've done before, but this is very, very popular now. In fact, I'm seeing it almost everywhere. And we'll go, it's 2 1-inch layers of drywall installed together in channels, and it works pretty good apparently. This is a view looking up in a wall. So here is this shaft wall liner. In this case, it's a purple one, and I can't remember which brand, with this little channel. And you see that we have a gap here, right? They're typically a 1-inch gap between the shaft liner and the frame wall. And these are the areas that we have to start looking. Are we getting air into those cavities, and are we transferring air around in these air spaces that we create in there? Because really well, I'll go to a next picture. So I hope this doesn't make you dizzy. So this is kind of looking up. So we have a floor truss system. This is an open loft area. So we have a main floor wall and an upper floor wall. Our truss is up here. And this is literally, like I say, 2 1-inch layers of drywall sandwiched together with these little H channels that it just slides in and interlocks. It's kind of an ingenious system. And then they put little clips from these metal channels and hook them to the wood frame. And we'll go a little bit deeper, and we'll see how this works. But as you look at that, if we drywall this, which is going to happen, and you put 1 or 2 layers of drywall on it, and you can, by code, if you meet certain requirements, put what? Electrical outlets in there, right? The drywall might not fit really tight up here. It might not fit really tight down at the floor. We have potential for air to get in behind the drywall. That's safe to say. If we depressurize this building after we got it drywalled, do we have paths created from the attic or from outside either end, the air that can get in and move through the spaces behind that? Now we have some fire blocking requirements that every 10 feet either direction we fire block it. And so they might take wood or drywall or something and put a block there so that the fire can't get through there, and do it every 10 feet going this direction. They can use rock wool product and just sandwich it in there. And that is legal to stop fire. Does a rock wool bat stop airflow? Not completely. We're going to have leakage through it. So if you're confused, I've got some better pictures that'll show us a little bit more what we're doing here. It's really important that we understand these concepts. So here we're building one, and you can see they put up the wall, and you can actually see that they have some of that material sticking up out of the top of the wall. And what's this guy doing? He's putting a clip on it. There's a little L clip that's made out of aluminum. He's screwing it to the metal channel, and he's going to do this on both sides, and then screwing it to the wood framing. Now, the manufacturer has all these requirements on how often you have to do them, and it depends on how tall it is and all this. I imagine you have these going up in your jurisdiction, don't you, Wendy?
We don't have anything really large being built right now.
You don't have any multifamily right now? Yeah. Well, if you have some come in, and I wouldn't be surprised if you did, maybe your zoning's not going to allow it.
No, there are some that are just duplexes.
Yeah.
That we worked on to come in, and there's one duplex now. That's it.
Okay.
We've had townhomes do that.
Yeah.
You get a row of 6 or 8 of them, and that's the fire separation right there.
They're doing it on townhomes, they're doing it on apartment projects, they're doing it on lots of things. In fact, they just built a hotel down here off 104th, and they did this in the hotel and wood framed the hotel and put it up through. So bear with me, we'll go a little bit further. So what are we asking this assembly to do? Well, number one, we're asking it to stop the fire. And that's critical, absolutely important. And we're doing it on every single multifamily project we do. They're required to put this type of, some type of fire resistant assembly in there. And then we, as energy geeks, or whatever you want to call it, we want to make sure that it's still an airtight building. And so we have to look at how we're going to do that. And then the other two things is sound and odors. And, you know, we do kind of have a disconnect. And I've already told you that multifamily projects don't pass at the same rate. And right now in Utah, the 5 is a little more forgiving because we've raised it 40% from 3 to 5 on the on the residential side. But come January, it's going to be a problem because the 3.5 is going to be a harder number to hit.
Are we going to have to start taping those seams then?
I don't think that that's where we need to go, but I have some.
Intermessing caulk on the seams.
Yeah, you can put some foam caulks, you know, some
Yeah, 'cause the foam
intermissing.
stuff, it expands under heat.
Yeah, yeah.
Do you find that more people choose the option of the blower door test versus just building it to the specs that you've provided that where they wouldn't have to do?
We're starting to see more and more of it, and what I saw, and Gordon might remember this, some of those multifamily projects we had in the county are after some grants and some extra funding, and so they did Energy Star, they did something which required them to blower door test them. And, you know, so there was other triggers for it. We're slowly moving this way. And the more we do, the less expensive they become. Steve, are you still doing them?
Yeah.
Yeah.
Multifamily getting to 3.5 is going to be very difficult.
It's going to be a challenge for them, isn't it? Okay. You build multifamily? Do you build multifamily?
Yeah.
And have you blower door tested any of them?
We're just framers, so.
Oh, okay. Well, they might be coming to you and say, hey, we want you to do something different.
Yeah.
And so you're using Rockwell mostly, is that correct? Or
We exclude it.
and let someone else do that? Well, I don't blame you.
There's still framing techniques that have to be employed in order to meet the prescriptive requirements. They're like, you know, how you frame a corner or something like that so you can get the insulation in there correctly. So, and I found that once you explain to the contractor the detail that you have to go through to verify all that stuff, they just go, heck no, I'll just do the blower door test. So that prescriptive list, I only had one guy in 17 years want to do it, and it was a nightmare.
Yeah. Yeah, Gordon's comment was, if you hold their feet to the fire on this list and say, we're going to do every single item on here, they're going to go, oh, no, I'll blower door test.
Yeah, there's multiple inspections that have to be made for that.
Yeah, this one's pretty tough. But when we get to it and we are blower door testing, they're probably going to come to you and say, hey, we need to change our process a little bit.
Yeah.
You know, and
That's why I'm here.
that's why you're here. Yeah. Steve.
Well, we found the only way that we can get the multifamily to even come close on the blower door test is to foam the party walls on the ends and on the top and the bottom, basically do a window with spray foam. And that's the only way because there's so much leakage in that party wall with all the spaces and everything like that. You just seal it from the outside, basically just a picture frame around it.
I'm glad you brought that up, Steve. What he said, for those out on the web, is the way that you get it to pass is you basically seal where that party wall hits the outside, you spray foam up and across and even below, and you picture frame the exterior of where those two units meet. And you really think about it, you have all that leakage in and out of that space, and guess what? What you're telling us, Steve, is that it's actually leaking to outside, because if you seal that, it passes. And so we can argue about, well, that's conditioned space on the other side, but that little 1-inch air space is communicating with outside, bottom, front and back, and the top. So yeah, I guess we could do a whole bunch of foaming and caulking at every level, but if we do it where it penetrates or where it communicates with outside, that's the place.
2-hour fire assemblies are pretty particular on what kind of material you can use inside that cavity. I don't know if the 2-hour assemblies have been tested with foam in them though.
The comment was 2-hour assemblies are pretty particular of what you put in there. And one of the discussions that, as I prepared for this, was that code officials are apprehensive to allow them to do something that isn't specifically listed. And there's discussions going on with UL and everything, because really some of them is foam really going to change, a little bit of sealing really going to change the performance of the drywall? And in most cases, no. Especially fire rated foam. No, they didn't test it that way because they aren't testing for air leakage. Does it have an impact? And so those are the questions that are trying to be answered, And the code officials, doing his due diligence and trying to say, well, wait a minute, can you really do that? And so maybe additional discussions need to take place. And that's what's happening right now. I'm glad you brought that up. We have a slide in here on it. And this is exactly what you're talking about. We have a fire-rated assembly, and here's a UL U373. And this, for those of you that aren't familiar with this kind of helps you a little bit. You see you got this H channel here, and you got a U channel that you cap, and then you put another U channel on it for the next one, and you literally just stack them like blocks, kind of. And then you have these breakaway clips that are installed at each floor level, and in some cases you have to do them intermediate depending on how tall and everything, and depending on the system. But it's you think about it, that's 2 inches of drywall. It's going to take, it'll hold for 2 hours. It easily will hold for 2 hours. And the whole idea is, notice it says breakaway clips. So we have a fire, we have a clip on this side, we have a clip on the other side, we have it all the way up and down the wall. We have all these clips. What happens if the fire starts over here and that side of the building collapses? The other side stays because the aluminum clips break away, melt, break away. And so it allows that. And then the clips on the other side hold the assembly up. Now, are you going to be able to just rebuild using that same assembly? I don't think so. But it did its job, and it gave time to save lives and to bring people in, to get people out of the building and to bring people in to control the fire before it spread through the whole building. There's a lot of resistance. Us code officials, we're kind of, am I safe to say, Gordon, we can be a little bit knot-headed sometimes and kind of stuck in our ways, and we resist change just like anybody else. And I know a couple of code officials that just had a fit when this stuff came out and said, no, we can't do that. We have to do the 2 framed walls, and we drywall them before we stand them, and we have to do all this other. If it passed the UL test, why are we worrying about it? But you bring up a really valid point. Can we do that stuff in there without violating the listing of that test? And that's the discussion that is taking place right now. And this is one. This is a UL 373, and then there's a 336 US Gypsum puts out, and it's similar. And these are too little for you to read, but they're all kind of similar, and they have these details that show where we have to put clips, and I know you can't see that. And we have details for where we have floor systems or walls tying into it, and different ways that we address this. And so the manufacturers of these have specific instructions on how that has to go together for these area separation walls. And here's how it works. And I just described you this, but this is probably a better way to do it. Here's a simple view. We have this party wall, this demising wall with shaft liner fire barrier, and this is put out by Georgia Pacific. They call theirs party wall aluminum clips. And the clips, as you get taller, will have to be in intermediate locations too, so you might have to put a block and tie them in. But you get a fire in this unit, and what happens? The clip here, here, and here, they can melt away, and this thing can just, this side of the building can fall away. And it's a good system. But what do we also see in this picture? We see a cavity that leaks. And as Steve mentioned, those out on the web might not have heard, the 3.5 is going to be a hard number, isn't it, for these multifamilies? It's going to be a hard number for them to hit. What are you running, 4, 4.5 typically? Yeah.
Unless they really try, you barely make 5.
So they have to try to make 5. Reason that we're talking about this today, isn't there?
So why do you suppose they don't come out with the UL listed air assembly or air barrier assembly? Wouldn't that help prevent some of the leakage that we have?
That 2 inches of gypsum's not leaking too much itself.
So what you're saying, UL come up with a test that another test, they set it up the same way as they did for the fire test, and then they do some sealing on it and see how it holds up too?
Well, I don't know. You say these commercial, or these, I guess the commercial side of the apartments and that, they're very difficult to get them to pass. Would it be that difficult if there was a UL listed air barrier assembly that they used correctly, just like the fire assemblies? Would that help make it easier or ensure that they pass the test? Instead of just leaving it up to the contractor, is one thought that went through my mind, you say that when they hit the 3, that triggers the what?
Mechanical ventilation.
Mechanical air thing. Okay, and I guarantee you, I can see a contractor going, oh, heck, a 3. He goes down there and he drills a hole in the rim board so it leaks a little more. Now it's not a 3 anymore. Now he can get away with it.
Well, he cracks a window.
Or something like that.
Yeah. No, Gordon's comment for those out there, the contractor might resist that and make sure that he doesn't go below 3 so he doesn't have to do it. You know, it's important for me to note that the real trigger, the code-based trigger, is 5. The state dropped it down to 3. So I guess they're going to do that. Does UL doing any of that? No, but what I found, and I'm going to have a few here, and we're going to hurry and try to get there, that there are some things, and I think Steve's recommendation probably nails it because we know that's where it's leaking. I don't know if we need a listed one. We just know that where it leaks. And that's the beauty of testing, is we can find out where it's leaking. And each building's going to be a little different depending on who framed it and who the plumber was and what components they gave you to do it. And Steve?
It's the most labor intensive, but the best thing is to move the air barrier to the sheet rock.
That was going to be.
And then you don't worry about the outside of the framing, the party walls and all that kind of stuff, but it takes every single box, every wire going into the boxes, especially on apartments that are 6 and 500 square feet. 3.5, figure that out.
Yeah.
It's like no leakage at all.
Yeah. Yeah, the comment was labor intensive, but it works if you do what? You seal the drywall. The drywall can be your air barrier, but what happens to the drywall? We have holes cut in it. We have wires run through it. We have wires coming into the boxes. So sealing the boxes and the wire penetrations and all that stuff can be pretty challenging. I mean, it can be really challenging to do all that. And cost money. You know, at what point is it, you know, you say spray foam and everybody just, it's expensive. You know what, it's probably not that expensive to spray that picture frame that he described around on the outside of the building, because that's really where the leak takes place. And that's what you identify when you blower door test. You know, they take smoke or theatrical fog or whatever, and they can identify where it leaks. Steve?
But then also you throw in RC channel and everything like that, and then you have to seal it at the drywall.
Yeah.
Once you create that huge cavity, that's RC channel and everything, there's no other way except to do it at the drywall level.
Yeah. His comment was when you throw RC channel, how many RC channel, resilient channel, it's a little metal channel that they'll screw on floors, they'll screw on walls between layers that it's a little C kind of channel. You screw it and then you screw the next layer of drywall into the raised portion of that so that we minimize the contact between two layers of drywall, and so we stop the sound transmission. And when we do that, we create another cavity for air, and you just about have to seal it on the face of the drywall. Really, my focus today was to make everybody aware of our challenges, because they are big challenges. And I think I threw in a slide for Denver and New York and maybe one other, but maybe I had to take a bunch out to get it to fit. But really, I'm not solving the problem. I'm helping you understand the problem, and then we can work at it from there. Sound, I'm just going to kind of skip through this, and that's a little bit of, you know, our sound transmission class ratings. This has become a little bit, actually a lot more important. And for the design professional, even though the code doesn't mandate it, we do have Appendix K in the IBC that addresses some of this stuff, because sound is an important thing to consider. The interesting thing, if you're trying to address insulation installation for sound and for thermal resistance, it really needs to be installed in the same manner. And we have all these different groups that give us direction on how to correctly install insulation. And like the Energy Code says, in accordance with manufacturer's installation instructions in this code, and this is part of the code, and National Association of Insulation Manufacturers Association, I believe is what that stands for. They have specific instructions on how to install for sound control and also for thermal performance. And guess what? It is to, it's the North American insulation manufacturers. The bats have to be fit tight, and all those things carefully cut around. So it's the same thing for that, and then ResNet also has their grade 1 installation, and it's the same type of list that we don't have voids or compression or, you know, and these are all really good lists, and that's really right here is what this table's trying to talk about, is how we install insulation. Me personally, for wall insulation, if you want to make it work well, do the bib system. If you're doing fiberglass, do a bib system, and just because you blow it and you fill it and it works. Okay, why are we talking about air barriers? Because insulation with an air barrier works. We can have our little fleece jacket, and if the wind's blowing, we're cold, aren't we? But as soon as you put the windbreaker over it, we're warm. Our fiberglass insulation is the very same thing. If we have air moving through it, it's like the little fleece jacket. Our rim joist, without something to stop the air movement within that bad insulation in that rim, is not effective. It's not effective. And the wind's blowing, or the air movement inside the space. You know, we actually want to keep that air static inside that insulation so it works. So these are some of the things that they, and this is the exact location that Steve was talking about right here. So here's an interior wall, and an exterior wall. And this is the spot right here that we have air moving back and forth within that. The wind's blowing against this side, so it comes in through there and goes through there. You put a blower door test on the unit, and it leaks air in here, and it finds all kinds of places for the air to leak into the space. And so his suggestion was, this is one of the places you can seal it also, and might be where you go. There's our challenge. I mean, that's really it in a nutshell, because we're going to have a minimum 3/4 inch airspace in there. And you can see it right here. And you can see it when the buildings are going up. You see that little gap there, and so what do? They come in and run siding over it, or maybe they run some foam, maybe an EFA system on there, but they're going to have to put brakes in that too for expansion and contraction. Pack and fiberglass really doesn't work. Closed cell foam works. And we have listed fire resistant foams that we can spray in there. We can fire black that with, I mean, you can put a scrap of your shaft liner material in there. You can put 2x material. There's a number of things that you can put in there, and these are all the things that are approved by the code. OSB 3/4 inch thick, or close to 3/4 inch thick, is an acceptable fire block, but also we're not just blocking fire. This is an acceptable fire block. It's not an acceptable air barrier. See here, they put an extra piece in there. You know, we have the same issue when we get up top. This shows you a little bit better. See, here's the clip, and then they've put a scrap of material in there to try to stop the air movement through there. Is it going to be effective without sealing on it? No, there'll be too much that gets through it. Another close-up view. So here's a scrap coming up through from the level below, but there's a clip there, there's a clip here, there's a clip here. This rock wool is acceptable, again, as part of the fire assembly, but it doesn't stop airflow. We just might have to be doing more of this. These are some guides that DOE has put out on areas that you can call conceal. They're all labor intensive. Going in and shooting that with spray foam, closed cell foam, sure, labor-wise is a lot quicker.
One down in the bottom right corner is a real good. That works really good. We've used it.
It seals pretty good, yeah. Yeah, Seal has been around for a long time, and it is pretty effective material. I need to shift that slide, don't I? Here's a unit before drywall, but you can see all the gaps between there. And this is one that you notice. You see the blocks? This must be a multi-story one because they're required on the lower levels to put the intermediate clip on it, so they have to block it and clip it. I've had some framers really upset with me because I told them they had to put the intermediate clips on. That's a lot of labor, isn't it, to go in and block the whole thing? Yeah. It is. You thought you were done, and then you have 3 days of putting blocks in, right? So what's the best practices? The goal is to complete air sealing of smaller gaps and seams that cannot be addressed by solid blocking. These aren't addressed in the UL assemblies or any of the other guides or notes, and not specifically addressed in the code. And here's the thing, and you brought this up. Oh, he left. Many jurisdictions do not allow air sealing of these smaller gaps and seams because these practices are not specifically detailed by UL and the I codes. And maybe I'm wrong, but I don't see how spraying foam like Steve described is going to impact the performance of that fire-rated assembly. I just don't see. Now, if I was the guy in charge, I would say it's okay. Now, maybe the guy in charge, maybe Wendy's going to say, nope, it's not on the listing, it's not on the UL 736 or whatever, I'm not going to accept it. But this is the discussion that we need to have, and this is the discussions that are taking place. Is there anything wrong with it? And discussing this with the people, just informally that I know at UL, they don't think so either. We treat the common walls as we would any exterior wall. We don't use the fiber mineral. I'm just whipping through here real quick. This is going into the attic there, so this part is important where we're going into the attic. And if this is on the outside wall, then that part's important. And it might be easier just have the guy come in and spray it quick. Right? That's pretty time consuming to run those 2 beads by hand. Well, the alternatives, jurisdiction initiative, code allowances, alternate area. We might use a different type wall. I'm just going to, because we're out of time. Denver has an amendment, and I'm not saying this is what we should do, and they have raised the number to 4, and the code official can allow the guarded blower door testing where you use multiple blower doors. New York State says the same type of thing. They're allowing the guarded, and they're not requiring testing of every single unit. And that's one of their solutions to it. The other thing is maybe one of the other earlier assemblies where we built the 2 separate walls and we did all the drywall and everything on both sides would work better. And I don't know if that's true or not, but we do have alternate ASWs that we can use that, here's a 2-hour wall with, it doesn't meet all the multifamily requirements, but 2 layers on both sides, that's a 2-hour wall. So I'm just going to skip through those.
The challenge with those 2-hour walls and the double layers, that first layer has to be taped, so the framer has to have the...
And multiple inspections while we're tipping them up. Yeah, they're really tough. This kind of repeats what we already talked about. And this we've already talked about. So filling those air spaces, especially at the perimeter of the building, is really what seems to work. Any questions? I know we're out of time. Great comments. Please.
Are there any other amendments in the Utah code that affect the energy usage outside of the air source?
They're all in here. So what they basically do is they change the blower door testing limits. They reduced, if you have duct testing required, they loosen that a whole bunch. They, one of the big things when they did all these amendments is they said we're not even going to consider the 18 code, so we're not going to adopt the 2018. And then they crossed off a couple of, and eliminated a couple of requirements. But the big ones are with the blower door testing and not making it mandatory but making it an option, and then loosening those, the test rates. Wendy?
Could you just briefly touch on the water heater changes, exhaust changes that are upcoming?
Yeah, there's a, is it January? July. Water heaters, because they create so many pollutants because of their nature and design. Water heaters and boilers, they have to be ultra low NOx, and that's effective pretty quick. And they kind of have like a catalytic converter type thing in there, little screen things that heats up, that burns the onion. No, you'd have to send me an email. Or you could search Doppel ultra low NOx or something like that. Nitrous dioxides. The challenge with water heaters, real quick, and if you need to leave, that's fine. What happens in a high efficiency furnace now? We have this chamber that goes back and forth, and we have this fan drawing air in, and we have this lots of air and lots of time basically for complete combustion. Plenty of air. How do we heat water in a water heater? We have a burner that comes up and it's like heating on top of our stove, and the flame hits the bottom of the water heater before the combustion is complete. And so we create more pollutants.
I've taken out probably 6 or 7 of the low NOx 80%er furnaces, and that catalytic converter's never still working, but when I take them out after 10 years.
Yeah, and the state statute doesn't hit for furnaces. It just hits for water heaters and boilers.
Bring it up because the same thing will happen with water heaters.
Yeah.
So we'll lose that.
Well, maybe they're improving.
Maybe they don't last 10 years.
Yeah. Thank you. Appreciate your comments and questions. We'll see you next time.
Don't forget to give me your survey.
I have cards up here if you want to grab one.